Hello again, everyone. In this session, we want to discuss DHCP failover. Now, why do we need DHCP failover? Why is it necessary on the network to have a DHCP failover system? Well, we want to know that if one of our DHCP servers fail or a scope fails, there's another DHCP server available on the network to give out the necessary IP addresses and configuration so that the client computers can communicate with each other and communicate with the servers in your network. So if the DHCP server is not available, it's not reachable, we need to have another server in place that will give those IP configuration settings out to clients. How does this work? The DHCP failover feature gives you the ability to have two servers, and both of these servers provide IP address configuration to the same subnet or scope. What happens is that the two DHCP servers replicate lease information between them, allowing one server to assume responsibility for giving out the addresses when the other server is not available. It is also possible to configure what we call load balance configuration, where you have the client requests being distributed between the two servers in the failover relationship. Failover allows you to have two DHCP servers, and for Server 2012, the failover relationship is limited to IP4 scopes and subnets. There are two modes that you can use for your DHCP failover configuration. You can have what we call a hot standby mode, or you can have a load sharing mode. The hot standby mode would be the DHCP server in the relationship that is on standby. Is on standby so that when the primary DHCP server goes offline or is not reachable, the hot standby DHCP server will take over and start leasing IP addresses and configuration needed for the clients on your network. So if you place your DHCP server in standby mode, it means that this server is the secondary server, and it will only start to issue addresses if there's a problem with your primary DHCP server. Here we have an example. You have server 1, you have server 2. Server 1 is the active server. The IP address pool is owned by server 1. Server 1 is going to give out all the IP addresses and all the configuration necessary. But if there happens to be an outage, then that role will be switched over to server 2, which is the standby server. And the standby server then will take over the address pool, but only after the active server transitions into what we call partner down state. Now, what we need to know is that we actually have to configure the servers and configure settings so that the standby server will know, well, How much time after the active server goes down should I take over? For the standby server, you have a percentage of free IP addresses that needs to be available to this standby server. And you can configure that percentage in the configuration settings for the server. Let's take a look. Addresses reserved for standby server. You always have to have a default percentage of addresses reserved for the standby server. If you set that number to 0, then there will be no addresses reserved for the hot standby server. And then your new clients will not be able to get the configuration they need in case of an outage on the primary DHCP server. Once the main server is up, the standby server will go back into standby mode and it will stop responding to clients. And this facilitates what we call the failback of the client back to the active server. So that was the hot standby mode. Let us take a look now at the load balance mode, because we can configure the failover either as load balance or hot standby. Hot standby we looked at just a second ago. Now we want to take a look at the load balance. In the load balance mode, we have both servers responding to the client. And this is the default mode for DHCP failover. In this mode, you have both servers supplying IP configuration to clients at the same time. And how the server responds depends on how you configure that server. The default ratio is 50-50. You can see here the local server 50%, the partner server 50%. So you as the administrator, you have to configure what we call the maximum client lead time, referred to as MCLT. And this determines the amount of time the DHCP server should wait when a partner is unavailable before taking control of the address range. And again, this value cannot be 0. The default is 1 hour. As an administrator, you can also enable what we call automatic transition. And you see here state switchover interval. So the automatic transition to partner downstate can be configured right here. To configure failover, we need to right click on the scope and simply click configure failover. You're going to be asked to specify the partner server that you want to use for failover, and you simply add that server name or IP address. And then you configure your options that we talked about. You have the maximum client lead time. You have the different modes, either hot standby or load balance. You have the addresses reserved for the standby server if you are in hot standby. You have the state switch over interval. And these are the settings that you need to configure when you are configuring the failover relationship. Now, once you configure those settings, The action will replicate the configuration of all failover scopes that are part of the failover relationship to the partner server. And this operation may take some time. And then what you need to do is to, on the partner server, just reopen the DHCP Manager, and you should see the scope appear for both the primary and secondary servers. Your DHCP scope will now be fault tolerant. If there's a problem with the primary DHCP server and that server fails, then the secondary server will start leasing out IP addresses to your clients on the network. This is the end of our session on DHCP Failover. I want to thank you for listening.